Good morning, guys. I'm gonna go over another video here for y'all. This is limits. It is covering over, continuing it at least where we left off. You're gonna see that I can't just use the substitution method. I mean, if I plug it in, it's not gonna work out. These are a little bit harder problems, and so it's using again factoring or in this time expansion. And so we're gonna go ahead and go through these notes, so make sure you're taking them. Okay, so first thing here, guys, is that, let me turn off the fan here, it's a little loud. If I look at this problem right here, I can see if I plug in a 0, most importantly, if I plug in a 0 for x on the bottom, well then I'm going to have a 0 on the bottom, which makes this undefined, and that can't be the answer. And so I'm going to have to work with this a little bit more to work this out. Oh, you know what? I am on the wrong sheet. Sorry about that, guys. All right, so you run into the same problem with this one. So if I were to plug in the 0 in here for x, at least on the bottom, again, and I haven't plugged anything in on the top yet, but I'm going to see that the bottom is 0, and that would make this undefined, which it can't be undefined. So what I'm going to do is have to, what I call, rationalize it. So what I'm going to do here is I'm going to rewrite this. Just like that. And to rationalize it, what I'm going to do is multiply by the top and the bottom, pretty much the same thing. Only difference being that instead of, if this is a minus right here, then what I want to do is the opposite. So I'm going to put a plus. Okay, so again, that's all I did. Instead of a minus, I put a plus, and I'm rationalizing it. That's what I'm doing. Okay, so essentially what I'm doing here is I'm going to try and get rid of this x by itself. Okay, so let me go ahead and work with the top part. Okay, and this is always going to be the case when you look at this. So I know it looks messy, but bear with me a little bit here. Okay, so this is just the top part. This multiplied by this, and I'm putting in parentheses so that we can work with it. So if I multiply, if I do expansion, square root of x plus 1 times square root of x plus 1 equals square root of x plus 1 squared. Okay. Square root of x plus 1 times 1 is square root of x plus 1. Okay. Do the same here. Negative square root of x plus 1. And negative 1 times positive 1 is negative 1. Okay. So what I see here is opposite signs here, so these will cancel. This is always going to be the case. These two middle terms is going to cancel, and that's the point of making one of them negative and one of them positive. So these two middle terms always cancel, and what's going to happen here is this is squared, right? So this will cancel with that. The square will cancel with the square root. So I'm left with x plus 1 minus 1. Okay? So I can simplify this a little bit more. I see that the 1's in this case also cancel. So all I'm left with is x. So after I simplify and do expansion with this up here, all I'm left with is an x. So I'm going to rewrite this over here. Oops. So I have an x on top. And on the bottom, I have all this right here. Okay, so just this multiplied with this. Okay, and like I said, guys, the point was to get rid of the x. So now the x is canceled. Okay, and I'm going to rewrite this again now. So since I canceled this x up here, I'm just left with a 1. And then with this right here. Okay, So now if I try and plug in the 0, okay, which I'm going to do, I see that 0 plus 1 is equal to 1. So I have the square root of 1 plus 1. Essentially what I'm doing now, I can do the substitution method. And I know that the square root of 1 is 1, so 1 plus 1 is 1/2. Okay, so my limit is 1/2. So I have another example here, and I'm just going to walk you through it because I already worked it out. Okay, so again, I started with here, and what I want you to see is if I actually plug in this 3 in here, the bottom becomes 3 minus 3, which is 0 in the denominator, and we can't have that. Okay, so I'm going to apply the rationalization technique. So here, see how I have a minus 1 right here? So I wrote the same thing, but now I wrote a plus 1 on the top and the bottom. So I'm taking all of this right here, and I'm moving it over here so I can work with it. Okay, so x minus 2 minus 1, square root of x minus 2 minus 1 times the square root of x minus 2 plus 1. So again, guys, what I see here is after I do the expansion, well, square root of x minus 2 times square root of x minus 2 is x minus 2 squared. Okay, so again, guys, essentially what happens is these cancel, so all I'm left with is x minus 2. Like I said, these middle terms will cancel again, and I'm left with a minus 1. So here, I'm left only with x minus 3 on the top. Okay, so I went ahead and rewrote it, x minus 3 on top. And you can see, remember, I'm trying to cancel the bottom part because that's what makes it undefined. And you can see now the x minus 3 will cancel with the x minus 3. And all I'm left with is this right here. And again, from this point now, I can go ahead and plug in my value, substitute, and in this case, I ended up with the same answer, 1/2. And so, again, I'm going to put it so you can see all the work. You can copy it. You can pause right here if you need to. Okay. So, the other technique we're going to talk about is called the simplification technique, and I already went through it with you. If I plug in the 0 here, that makes this whole function undefined at that point. So the point is to try and get rid of this part, the bottom part, the fraction. Excuse me, the bottom part of this, the denominator, because that's what makes it undefined. So essentially what we're going to do here, okay, you should be able to cancel this part. So this is called the simplification technique. You're going to see, guys, it's not really so simple, but I'm going to rewrite it over here. And essentially what I'm doing here is I'm just working with this top part right now. Okay, so I'm going to rewrite it the way it's shown right here so you can see it. So I haven't done anything to the problem yet. And what I want you to pay attention to is now, again, I'm only working with the top part. I'm going to try and simplify the top part so that I can work with it. And I cannot add, excuse me, in this case, I cannot subtract these two because they don't have the same denominator. So what I'm going to do here is I'm going to multiply this over here, this part of the fraction by what I have over here, this denominator. So this will be 5 over 5. Okay. And I'm going to multiply this fraction over here by this denominator. So over here I have 5 plus x. I'm going to go ahead and put these in parentheses. And 5 plus x. Now, essentially what I've done here, now I have the same denominator. So now I can make them subtraction. Now I can subtract them. So now what I have on top is, well, 5 times 1 is 5. Okay. Oops. And right here, I'm going to keep the denominator. So I'm going to put 5 multiplied by, well, x plus 5 or 5 plus x is the same thing. Okay. So, same denominator, this top part was 5 times 1, and then I'm going to put a minus sign. So here, 1 times, well here, we can call this a negative 1. So negative 1 times 5 is negative 5. Okay, negative 1 times x is negative x. Okay, and so what I see here is, excuse me, let me go ahead and continue here. Don't forget, you still have this x over here. Is these cancel, the 5's, and I'm left with negative x divided by all this stuff, and then divided by again by x. Okay. So at this point, guys, now I'm going to do that keep flip change. Okay, and so again, right now I'm just working with this right here. I'm just rewriting over here. So negative x over, 5 times x plus 5. And then right now, what I'm doing is I'm dividing by x. So now when I do the keep flip and change, this is going to be negative x. So keeping the first piece of this, and then multiplying by, well, this one I'm going to flip. So this becomes 1 over x. Oops. And really, this is what I'm looking for. This is what I want. So here I see an x up here, and I see an x over here. So now these cancel each other. So I'm left with, let me go ahead and put the limit again. All I'm left with is 1 on top, and then I'm going to go ahead and distribute this. So 5 times x is 5x, and negative 1. Don't forget the negative sign. And 5 times 5 is 25. So at this point, and I'm going to go ahead and plug in the 0. Okay, so 1 over 5 times 0 plus 25, which pretty much, negative 1, which makes this negative 1 over 25, like this. Okay, so this is my final answer. Okay, so again, guys, I went ahead and worked out the next problem just so you can see. You can see right here, I went ahead and simplified the top part. So again, if you plug in a 0 here, you're going to see that it's not going to work. So I need to try and cancel this x here. So the original function right here is 1 and 3 plus x, and here's 1/3. And then again, here I multiplied by 3 because that's what I have over here. And over here I had to multiply by 3 plus x. Okay, so I went ahead and just simplified it over here. I can go through this part with y'all. So right here, what I did is 3 times 1 is 3. Oops. And this is 3 over 3 plus x. What you're seeing over here is just that I simplified it. So 3 times 3 is 9, and 3 times x is 3x. So negative 1 times 3 is negative 3. Negative 1, negative 1 times x is negative x, so that's a mistake on my part. This should be a negative. That's going to be carried through all the way. So okay. So now you can see that these 3's cancel each other, so all I'm left with is negative x on top over 9 plus 3x. Again, I just distributed that. And again, I'm going to go through the entire thing, and when it's all done, I plug in the 0, and a equals 1/9. So again, I'm going to go ahead and just put this like this so you guys can see it, all the work together. And that is today's lesson.